Hello students, welcome back. In the previous video, we breezed through the first three sections, and then now let's go over to section 4. This one is also easy, so we can move rather quickly here as well. Algebra of fractions. I haven't seen students making some mistake. I haven't seen many students making mistakes here, multiplying two fractions. Just multiply the numerators and denominators separately. That's about it. For division, I have seen some students having trouble, but if you just remember one thing, you'll be just fine. There's no distinction between division and multiplication. Just multiply the reciprocal. Flip over the c over d, into d over c. Pay attention to this red part. Just reciprocal, flip over. And then you just have multiplying the numerator and multiplying the denominator. That's about it. How about the next one? It's just taking common denominator. It's really no difference between numerical computation that students have been doing for a long time, as a matter of fact. And how do you do this kind of computation? 5 times 7 cross multiply plus 2 times 3, and then divided by 3 times 7, and then you do further computation, right? Yeah, this is exactly the same as that, except we have characters instead of numbers. That's about it. No problem there. Finally, this was quite useful when you have some really ugly looking fractions. If you have denominator of numerator, denominator of denominator, too many denominators here. How do you simplify? Just remember, if you multiply the same thing to both numerator and denominator, same non-zero number to both numerator and denominator, then it's okay because essentially you are multiplying by 1. So which same number do I select? Strategically, I selected the product of the denominators, b times d, so that b here and that b will cancel each other out so that we get ad in numerator, and this d and that d in denominator cancel each other out, and we end up with bc in the denominator. So we have three fractions here. Denominator, big one, and the denominator of numerator and denominator of denominator. Now we have only one fraction. And how do you simplify? Strategically, we select some quantity to multiply both numerator and denominator. And the best one is the product of the denominators. Okay, next topic, absolute values. Well, I don't think there's any need for any more time here. Absolute value is just a number part. Absolute value of 7, for example, is just 7. Absolute value of -7 is positive 7, so we need extra negative to make it positive. That's about it. Now, exponent rules. Okay, all right. How about the first law? Is everybody familiar with this? 8 to the nth power is just 8 times 8 times 8 times 8 repeated n times. It's just a shorthand of it. Okay. All right, no problem there. Next, 8 to the 0 power is defined as 1. Its definition, so don't ask me why people decided to do it that way, because it was very convenient. 8 to the 0 power is not 0. 8 to the 0 power is 1. And how about the negative power? Negative power is just reciprocal. For example, what do you have? 2 to the negative 5th power. It's 1 over 2 to the 5th power, because negative power is denominator. So it's 1 over 2 to the 5th power. Turn out to be 32. 2 times 2 times 2 times 2 times 2, that's 34. How about the next? Fractional power is actually a radical. How about this? 8 to the, 5 power. 5/3 power, excuse me. Yep, okay. What is it? It's this one. So 8 to the 5th power, but third radical. How do you calculate it? Well, if you don't have calculator with you, then how do you do that? It's going to be foolish to calculate 8 times 8 times 8 times 8 times 8 without calculator and try to find out cubic root out of it. It's foolish. Usually it's better to reduce the number first and then do multiplication later. What is cubic root of 8? It's 2. 2 times 2 times 2 is 8. So it is 2 to the 5th power. That's much easier that way. As for the other rules, well, yeah, I hope everybody remembers. And we have some problems requiring those kind of things in our homework problem. The homework set 0, the extra credit homeworks. But in this class, we are not going to be coming back to use these until we get to chapter 6, I think. Yes, chapter 6, exponential logarithm. So it's going to be another 3 years until we're going to be needing these two. So I'll say these two are postponed for the time being. If you do remember, that's fine, that's great. And you can go ahead with those extra credit homework sets on review materials. All right, final topic here is to take care of some mistakes. Here we go. These are rare cases that the separation works. Separating addition, okay, this is just distributive law. And separating the numerator, okay, that too works. But then again, all these are no's. No, no, and many more no's. No, 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 no. You cannot separate addition for squares or cubes or nth power. You cannot separate addition for fraction. You cannot separate addition for any kind of radical, and examples abound. They're all no. Interestingly, they're all multiplicative. You see, these are true. A times b squared is a squared times b squared. And then all these are true. Why? That's because nth power was defined by repeated multiplication. So this was multiplicative to begin with. That's why you can separate multiplication. As for fraction, that's division, and division is no different from multiplication, just multiplying the reciprocal. That's why we can separate multiplication. And as for radical, well, radical is, as a matter of fact, defined from, radical was defined from repeated multiplication. What do you mean by x is square root of a? That means x squared is equal to a, and x was greater than or equal to 0 as a matter of fact. Because here there are two possibilities. X squared equal to a, okay. Then negative x is also a possibility here, so we have to restrict it. In any case, you see, radical was defined from repeated multiplication. So yes, it works for multiplication. But as for addition, no. Interestingly, I don't see many mistakes about multiplicative part. Students usually handle it okay. For additive parts, I see hordes of mistakes. A fair warning again, I look for these kind of things because these are so typical. Okay, so much for section 4, and let's talk about section 5 in the separate video.